So as we mentioned before, we can solve these quadratic equations by factoring, because factoring essentially gives us the zeros of the quadratic. So basically what we can, the idea behind solving by factoring is we're using an important property here called the zero property of multiplication, meaning that if we have multiplication of two factors, or not just two factors, but of any factors, if the factors equal 0, then that means that either the A must be equal to 0 or the B must be equal to 0. And they can be equal to 0 and the other one not 0 and still give us a product of 0. So in this case here, if I have the factor x plus 3 times x minus 2, okay, this x plus 3 could be equal to 0, which means that x could be equal to negative 3. Okay, when that factor's x is equal to negative 3, that factor is equal to 0. Although this is going to be equal to negative 5, negative 5 times 0 is still going to be equal to 0. The other x that can make this equation work is when this is equal to 0. So when x is equal to 2, now we have a 0 here. And although this is positive 5 times 0 is still 0. But they both give us solutions. So x equals negative 3 and x equals positive 2 are solutions to this equation. And again, because the parabola has this shape, it's going to give us, we should expect that there's going to be two solutions. So that's how factors can be used to solve quadratics. So if we factor this here, two numbers that multiply to 20 and add to negative 12 are going to be negative 10, negative 2. This is equal to 0. And again, it's important that it's equal to 0 because now if it's equal to 0, we can use the zero property of multiplication. So I can say that looking at this factor, x could be equal to 10. If I look at the other factor, so first of all, if x is equal to 10, this is going to be equal to 8. But again, 0 times 0 times 8 is still equal to 0. So 10 is a solution. Here, if I have x equals 2, that's going to give me a 0 here. So negative 8 times 0 is still equal to 0. Again, since the factored form and the general form are the same, it doesn't matter. I can plug 2 into here and get 4 minus 24 is negative 20 plus 20 is equal to 0. It will work, whether it's in factored form or the general form. So basically, what we want to do is we want to be able to, as long as we can make it equal to 0 and then factor, and it's important, it has to be equal to 0 for this to work. So if I take a look at this equation here, I want to make this equation equal to 0, so I'm going to subtract x squared from both sides. I'm going to subtract 2x from both sides. I'm going to subtract 5 from both sides, and I'm going to end up with equaling 0. So that's key. It has to be equal to 0, but once it's equal to 0, if I factor this, negative 3 times negative 1, now the x's that solve this solution are much more easily found because I can now just look at these two these are called linear parts. This is a quadratic. These are linear parts because these are degree 1, degree 1. So they are what we call linear parts of that quadratic. So I can just look at the linear parts independently of each other. So x can be equal to 3. And again, it doesn't matter what's going to happen here when I plug 3 in, because anything times 0 is equal to 0. Here, x could be equal to positive 1. And again, I look at that independently of the other bracket because regardless of what's happening in the other bracket, this is equal to 0, which makes the equation equal to 0. So there's my two solutions. So it's key to be able to factor. So remember that the ones with the x, the coefficient in front of the x squared, we have to be a bit more careful, but we have to start becoming much more fluent with factoring these. Okay, we can't spend it all day, so make sure you have a good strategy. So if I were to factor this, I'm going to use my grid factoring. So this is going to be 6x squared. I'm going to end up with negative 4 here. And I know that the diagonal product, negative 24x squared, must be on the other diagonal here. So I want to split up that 5x. To get negative 5x, that multiplies to two numbers that add up to negative 5x, multiplied negative 24. Those factors are going to be negative 8 and positive 3. And that's going to give me the same diagonal product. So then that allows me to now factor. Okay, I know there's a 2x here. Here there's going to be, well, there's just going to be plus 1. Here there's 3x. Here there's negative 4. So factors to 3x minus 4 and 2x plus 1. Since it's equal to 0, I can look at these two factors independently. So here is back divided by front. So x is equal to 4 over 3. Here it's the opposite, and back divided by front. Okay, so when I plug negative 1/2 in, I'm going to get negative 1 plus 1 is 0. So where would I expect the graph of this? So it's the same quadratic here. Where would I expect the graph of this to cross the x-axis? Well, I would expect that to cross the x-axis at negative 1/2 and positive 4/3. And since it's a positive leading coefficient, it's going to look like that. Okay, it's going to cross at negative 1/2 and positive 4/3.